Preparing. Look for the symbol upper left.
Got it.
It's going.
We got it. By golly. Hey, hey, hey. Welcome aboard, everybody. It's our big 37th podcast, a weekly get-together of the guys from Santa Barbara Astronomical Unit. Now on the screen, the SBAU Astro Hour on Zoom. Among the various members of the board and other members, South Coast Local Telescope and Astronomy Club, SBAU, and for members or the general public, you can watch us live on YouTube, ladies and gentlemen, every Monday morning, 11 to noon, or replays anytime later on. It's all archived on there too. We kick around the latest space news, sky charts for night viewing, and some heavy astrophysics, which our SBAU brain trust on the screen tries to make understandable for everybody, including me. My name's Baron Ron Heron. You're invited to submit comments or questions below, folks. And we would love to have you as a member of the club, which we're keeping alive until we can get off this pandemic, get our masks off and meet at Farron Hall again. We might be doing some star parties. I'll talk to our outreach coordinator here in a minute. Let me introduce you to the gang. President Jerry Wilson, good morning. Good morning. Still hanging in there from our man caves and dens and computer lairs. Jerry's married to Pat Forgy, a very active lady. Chuck McPartland is our outreach coordinator. Post a little sad posting every month, not only in the newsletter, but online, saying nothing going on except our podcast.
Yeah.
And a few what do you call it? Occultations in the middle of the night for you, but that's not really an outreach. Man running the show on my screen upper left is Tom Totten, whose wife is Suzanne. Chuck's married to another Pat, our merchandise manager. Tom, webmaster, technical wizard, former president. And let's see, Bruce Murdoch has not joined us, but there is our former Westmont College science man, editor of the newsletter, Mr. Tom Whittemore. And his wife, Maureen, is somewhere in the house. Gentlemen, welcome aboard. Can I give you quick headlines, what we're going to be talking about this hour?
Good morning.
Yes, good morning. Jupiter's Trojan asteroid, we launched a couple of weeks ago, going there, and we're going to talk about a launch coming up in about, I think, 2 weeks from Vandenberg, going out to determine in the asteroid belt if we can redirect to, I guess, an asteroid. We'll get to that in a minute. And the long-delayed gotta work perfectly James Webb is now in French Guiana, which is northern South America. Left 26th, I guess, of September and has arrived down there. Took about a 16-day trip or something. 13 days, but it's going to launch.
Gentle cruise.
Yeah. All right. I hope we can talk about those things. And then the NASA AA asteroid. I can't read my own writing. Asteroid is what I made the A large. It's called the DART, and it's launching. That's the one launching from our county, right?
In Vandenberg.
Okay. But let me make a couple of quick announcements. Then we're going to peruse some of Jerry's crazy cartoons he forwards to us. One of our stalwart members, I hope he's on duty and listening, Joe Doyle, emailed us this, quote, I had a good fortune to sit under the starry vault last night, that was on Friday, discovering a big asterism. Something I've been learning about recently is these asterisms. Well, here's the Joe Doyle asterism. Look to him, he said, like a big airplane coming right at him out of the sky. He dubbed it Astral Plane. It starts at Almagro, star we talked about last week, and uses the three main stars of Triangulum and the three main stars of Aries. There's the picture. To me, that looks just like the W in Cassiopeia with a few less stars. But,
Cassiopeia wannabe.
That's not Cassiopeia, though. But
no, it's not.
No.
The angle's wrong.
Well, Joe has a very good imagination.
Yeah, he's into the mushrooms. He and Connie love them. I have them come back. Yeah, we light up some crazy cartoons. You folks that aren't lucky enough to get these or find them, you want to go to the first one. Let's see, the new house, the couple being shown a new home. And the lady real estate agent is trying to explain this big jagged hole in the floor of the main room.
I don't have that one.
Oh, you don't have that one? All right.
No.
Well, it's not going to do any good. Well, actually it does, because the hole looks right out into the universe. It's a black sky. They're looking down, there's stars. And the lady in the background, realtor, says, Well, of course, the real charm of this place is that hole in the space-time continuum. You didn't get that one.
I think that might be an old one. Huh?
I
That's
know.
what
I
I
think-
didn't-
Next week.
I actually
what?
got the one where they pushed the elevator and got to the top. Remember that one?
Huh.
Don't
An
push that
alternate
top
caption for that one would have been, "My God, it's full of stars."
And this says, due to less pollution, the Universal logo is now visible at the beginning of those movies. Remember movies, guys, when we all went to the movies?
Mhm.
Can you call up the tragic accident on the moon, or did you not get that one, Totten?
I don't think I have that one. Yeah.
Okay, well, then we'll save it till next week, and Jerry, you can forward it to him again.
Okay.
Hang On as a cartoon build as Speed Bump. This is kind of cute. It's very Gary Larson-esque, Far Side type stuff. Interesting, cute little creatures, because I didn't recognize them. They're spiders, I guess. And they're hanging in a row right next to that little physics thing that, here it is.
Yeah.
A fifth spider is being dropped down against the four that are hanging in a row, sweeping in to knock the guy on the end out. And we see him go, I just hate physics class. Gee willikers. I'll never understand that. If there were two coming down, two on the left would go to the right. Somehow
That's
it
right.
does that. You guys
Yeah,
all
right.
understand that. I don't. Now, the biggie.
Well, hold, let's get an explanation of that. So Jerry, Tom, so what's
It'd be
going
half
on
the
here? What are they,
It's magic.
It's-
I mean, it's something about, was it conservation of something of
Momentum.
energy?
It's
Momentum.
momentum.
Well,
The one on the right that swings down, it hits the first one. The first one passes the energy through, the kinetic energy through it to the next one. And then it goes out to the third one. And then the third, they all have to be in contact. These are not in contact, so that's not physically correct. And then the fourth one ends up with the kinetic energy, but it doesn't have anyone to pass it to, so it swings off the end.
Yeah.
The other three in the middle act as a transmission rod for to travel the wave down through.
Do any of you have that little 5-ball toy?
Not at home, but we used one at Westmont.
If there were 5 in a row and you pulled away 3 and left 2 hanging there, would the 3 knock 3 out, including the third one that came in? Do you follow me there?
Yes, it would. That's
Mhm.
exactly right. Good intuition.
Well, that's what Tom wanted, Tom Totten, and I don't think we're going to even learn, even if
Okay.
they could explain it. So,
And if you had 5 coming down, then 5 would go out the other end.
of course, it wouldn't hit anybody. Well, let's go to the big one that headlined or began Jerry's talking points, and I call it, what do we call it? Hang on. Oh, no, back to standard time, something we all did
Oh,
over the
sorry.
weekend.
Yeah, that one was
go
pretty.
ahead. A
pretty
pair of ancient Celts, some Celtic workers having to rearrange those huge and heavy blocks of granite. One of those Stonehenge circles that were aligned for the sun there, are used in religious rites ages ago. Man, guy says, I hate it when the clocks change. There it is. Tim Crawford, one of our stalwart members, emailed us back. He really liked that one. That's funny.
Yeah.
Miss Gary Larson, don't we? But he's around. All right, gentlemen. We got lots of stuff to talk about. Venus and M8, Fomalhaut, the James Webb. Now, how about the one in the county? Can we get that out of the way since that's as close as we're going to get? Vandenberg Space Force Base.
Sure, that's DART.
DAR2. DART.
DART.
Okay. Why our county and not not Canaveral, do you suppose?
Boy, I don't know.
Availability.
Maybe they're
I
trying.
bet.
Yeah, it's not Vandenberg Air Force Base anymore. It's Vandenberg Space Force Base.
VSFB. Well, that means it's a polar orbit to get it in orbit, and then it's going to head out, I guess, for what is this the one that's going for a year? Almost a year. Next fall of next year, it's going to arrive in the asteroid belt, right? And let me read
It
what's
takes longer than that to get out there.
Yeah. I think they're using an ion drive to get there,
Yeah.
and they're not exactly a fast accelerator.
Well, they wouldn't launch with an ion.
No,
drive,
of course.
right?
No, nope. I think they're launching on SpaceX.
Wow.
One of the what do they call those? Dragon?
Falcon 9.
Falcon, that's it. Yeah.
Okay, the Canaveral launch to the Trojan asteroids of Jupiter, that's going to be 12 years. That was a couple months back or a couple weeks ago, right? That's on
So
a-
Baron, here's the web page. It talks about gridded ion thruster, next-C, next ion engine test firing. So they're using that, I think, on the DART mission.
That's going to call for a big explanation on one of our future shows, Jerry.
So
You
3
and
times
Chuck.
as powerful as the Dawn in deep space, one spacecraft.
Mhm.
It's like throwing bowling balls out of a canoe.
It's
Do they float?
You don't care. Once you throw them, you don't care.
ions. Okay. Is that a first? We haven't used those before. The ions.
No, they've been
Sure we have.
developing ion engines since the 60s. So I know
Really?
they worked on them at Hughes Research Laboratories in the 60s.
And do they save money on fuel by using that?
Yeah, they are far more efficient at traveling long distances over long times. Well, not so long time because it's a very low acceleration, but it accumulates over a long period of time, and you can get up to higher speeds eventually. The chemical rockets get up to their high speeds right away. So they're good for getting out of the Earth's orbit or getting, not necessarily out of the Earth's orbit, but getting off the Earth's surface. These ones, once you travel around in it, leaving your ion trail behind so Star Trek can track it, they just keep burning forever. They throw ions out the back. They're not very heavy, but they throw them at very high speeds. It gives you a big impulse.
Well, plus they pick the heaviest ions they can manage.
Yeah,
So
And the
is xenon, is that a noble element?
yeah, it's an inert gas.
Uh-huh.
It's a noble gas.
So how would that be ionized then?
What? Oh, you can ionize it. Okay.
Yeah.
And something about that propels the rocket ship.
Well, they have different ways of doing it, magnetic fields or electric fields. Simplest way is an electric field. And once you get an ion in the electric field, you put a negative charge plate in it, and the ion is negatively charged, so it repels the plate. So the ion and the rocket repel each other electrically.
Okay, we're talking about DART, right? Double asteroid redirection.
Well, I was talking about ion drives in general.
But this DART launch is using the ion, right?
Yes,
No.
it is.
No,
Oh,
it's not using it to launch, Ron,
Right.
but
I
the
understand
spacecraft is using it to travel.
But
Right.
the one going to the Trojans is not using that.
It probably is also.
Yeah.
Oh, well, this is what came from your talking points, Jerry. The target is not one, but 2 asteroids. One of them is orbiting the other. Dimorphos circles bigger Didymos.
Yeah.
And they're gonna-
Demos, yes.
Yeah.
Didymos, and they're going to deliberately crash this baby. It doesn't have many instruments on board. I think it only has the camera, right?
Yep. Just a camera. And they're going to crash it at high speeds into the smaller of the 2 orbiting asteroids. And then they're going to use Earth-based telescopes to remeasure very precisely any changes in the orbits between the 2. So
I
they want
see.
to know how much effect they can have on a solid asteroid like that.
I got you.
I'm assuming that it's not a gravel pile, otherwise they'll just disappear inside of it.
Yeah.
Uh,
But they want to
Jerry-
find that out, I'm sure.
Yeah.
it looks like it's a head-on collision, and it's slowing it down so that it gets closer to the bigger asteroid part of the double.
Yeah.
And
If
it's
they hit it
all-
right, that it will slow it down. That'll change its orbit because it will have a smaller orbit. But if they hit it the other way, then they will make it have a bigger orbit.
Mhm.
Aha. And it's being done to save us in the future, in case. The only thing I didn't realize
The
was
Space
I thought one-
Force's primary mission is planetary defense.
Oh,
And this is an early test of that.
okay, but they got to find the one that's heading this way somewhere.
Well, this one is not necessarily on a collision course, but they want to just test the technology.
And they would be able to see from a distance using a telescope or the Hubble if it's
Well, it's a 2-part spacecraft, and one part is going to observe, and plus then we're going to observe in the future how the orbit behaves.
Right.
Okay, observing how? With a telescope or the
Yeah,
Hubble or?
ground-based.
Telescope, radar, occultations. I mean,
Oh.
I don't remember if this double was discovered with occultations, but I know before they gave the moon its name, they just called it Diddy Moon.
Didymos. DIDYMOS. Have you ever used those in an occulting?
Well,
department?
yeah, these were seen in occultations, and I think before Dimorphos got its name, they called it Diddy Moon.
Yeah.
Uh-huh.
Now, the window for launch for this from Vandenberg is between November 23rd and February of 2022.
Oh, that
So
long.
if the weather permits, whenever they, somewhere when the weather's good, between those dates, they're going to launch it.
They want good weather.
Well, actually, I think they have to, if they can't launch in November, they have to wait until February before they can launch it again
oh, so
to
there's,
get another window. And then there's probably other ones in the future if that one's
Yeah,
blocked.
their sentence here is ambiguous. It says, if required, more launch attempts will be made until February 22
okay.
at the earliest. So they left out the word no launch attempts.
Or
Yes.
yeah,
gotcha.
or just worded it poorly.
Yeah, it's ambiguous wording.
Chuck, do you have any idea how many asteroids have names?
Oh, God, thousands.
Thousands.
Oh,
Well,
yeah. It's not tens
Tom-
of thousands.
Tom Whittemore was going to talk sometime about star names. We might follow that up with names like Didymos and Dimorphos. Asteroids
Yeah,
are us.
It used to be that people who discovered them could give them the names.
Mhm.
But then you got this guy in the 70s that discovered an asteroid and named it Mr. Spock after his cat.
Yeah.
And so now the IAU kind of controls the naming.
Well,
Yeah.
except
Tom, could you show the picture of the dart approaching the asteroid in an artist rendering that's in the talking points?
I think I have it right here. This one,
No.
the other one. Let's see. Go back to that one. Stop share.
launch time on the 23rd is at night, 10:20 p.m. There's going to be
Yeah.
a crowd up there in Lompoc.
That'll be pretty if the sky's clear.
Mhm.
Heck, Channel 3 might
Well,
broadcast.
this one will do too. This shows the spacecraft. Oh, there it is. This is the spacecraft dart approaching the asteroid. There's another asteroid off to the right. You can see past the solar panels. And then it's heading for the little one like this. This is an artist rendition. It's not necessarily the asteroid. And that's a representation of an ion drive that's powering it to keep it up for the crash. And then the picture below that is the one that shows the spacecraft in the clean room at wherever it is. Yeah, that one at SpaceX. So that's the satellite, that's the DART satellite getting ready to ship. It's all wrapped up in its gold Christmas wrapping.
Wow.
That's the one that's going to crash.
That's the one that's going to crash.
And the one
And-
that's and there's a piece on there that will be the observer.
Yeah.
It's a
And-
CubeSat, right?
Oh no, I'm yeah. Yeah, there's like a little tiny one.
That'll be left behind and won't crash.
Right.
Oh, and that way we'll get a picture of the crash and we'll get the crashing part going right in, just like
Yeah,
they used to do it
it's-
on the moon.
It's not intended to crash, the camera.
That camera, yeah.
Yeah, that camera.
There's a camera
Yes.
on the crashing piece. This is just like the Comet crash mission that was done several years ago,
Mhm.
where they put an impactor in the way of a comet and watched the impact.
Well, we've had camera laden probes go into the moon too, haven't we? And
Yes.
all the way down and then just go to fuzzy.
Yeah, Ranger did that.
Is that what?
I think that was the first one.
Wow. What's amazing to me is if you crash on something with that low a gravity, it might just shatter and then go back out into space as debris. What might it? It's not going to stay on the surface of that.
That depends entirely on what it's made of and how strong it is.
Okay. Fascinating stuff. DART, double asteroid redirection.
Oh, here,
Well,
Brian. Bruce is coming in, and I just wanted to show you that also NASA, they want you to protect or see if you qualify for the asteroid defense mission. And if you answer their questions, let's see, you get a certificate. So this certifies that Tommy Totten is officially declared a planetary defender on NASA's double asteroid redirection test.
A planetary defender?
So I had to answer 5 questions. I got them all correct.
Is that right?
So did you put your name in that way?
Yeah.
Okay.
Pretty good.
Well, next time we have a meeting, bring it, whatever you got,
Mhm.
certificate or a medal. I
Have
congratulations.
to print it out. Yeah.
Okay, so
It's all
that-
digital.
is this the first launch on an interplanetary basis from everything else has been,
No, this is probably the second.
what was the first that went into space and went somewhere else from our?
It was pretty
Spaceport?
recent. I don't remember what it was. Oh, the first I think might have been the one to Mars that was the InSight.
Really? That came from Vandenberg?
Yes.
Okay, that's not Perseverance. Oh, that
No.
was
It
before.
was pre-Perseverance.
We've launched a lot of Earth orbiting satellites from Vandenberg too.
So do
Okay,
you think there's an advantage from launching from Vandenberg to get out to the asteroid belt?
I don't know.
I don't know. It's best for polar.
yeah. Well, what do they call that speed that you got to reach to get out of orbit
Escape
around the
velocity.
Earth? What escape? It's higher than 17,000 miles an hour, isn't it?
Yeah.
That's the velocity you go around the Earth, I think,
Yeah, 11 kilometers a second.
or 5 miles or 6 miles. Anybody want to talk about the old Webb?
Yep.
Since we only got so much
Oh, yeah.
time. September 26th, they shipped it to northern South America, to the ESA spaceport down there at
In Kourou, French Guiana.
French Guiana. You want to take it from there? Anybody? When it's going to go up?
No, you're doing good.
Okay, well, it's going to be launched on December 18th on an Ariane 5 rocket, which I guess is European. And it'll be a 1-month trip out to the Lagrange point L2, which is the part
Behind the
of,
moon.
yeah, you can take,
Behind in the Earth's shadow.
well, all right, jump in here anytime you want. You've tried to explain Lagrange to me, guys, and I understand the Lagrange point 1 in between us and the sun. That makes perfect sense to me, that our gravity and the sun's gravity would cancel out and it would stay there. This one doesn't. Why doesn't the sun and the Earth combine and pull that sucker back in?
Well, it's orbiting the sun and it's orbiting the Earth. It's orbiting the sun along with the Earth. So the sun is pulling it in. That's how it has an orbit there.
It's
So-
falling all the time.
Yeah. So it's like holding hands with the Earth as the Earth goes around in the sun, or goes around the sun in the year. It'll stay that far out.
But then
So-
there's L3 and L4, right?
Yeah,
There
but
you
let's
are.
not revisit that discussion
All
again
right.
this week.
Okay, gotcha. But in any event, everything's got to work. There's, instead of 7 minutes of terror, which the Mars landers gives people at JPL, this will be 30 days. Something's got to
And
happen.
they also have a number of single point failures in their systems.
Bruce Murdoch has joined us. How are you, Bruce? Good morning.
It only took me 20 minutes to get logged on. It kept throwing up on me, but
Well, quit giving it booze. There it is. Look at that. It's got to fold out. It's got to have a
Yep.
4 tennis court size shield.
So the first of Bruce's single point failures, it's going to take 8 minutes to get off the Earth and into space.
Right.
And then it's got to start moving out toward its Lagrange point. The solar panels will come out at 30 minutes after it launches. And it's the first of 50 deployments and is a critical step since the spacecraft needs power from those panels. It has no other source of power on board. About
Okay.
12
they've got to
hours
have
in.
batteries to make it smart enough to know what to do to get the panels out.
It says there's no other source of power. There might be storage, if that's what you mean. Maybe that's how a battery qualifies.
Yeah.
Batteries
About
and
12 hours into the mission, will fire the Webb will fire its engines for its course for L2. 3 days later, the sun shield pallets that are shown along the front of the backsides of the main mirror will fold down. Once that's complete, the mast holding the main mirror will be jacked up to clear the sun shield. Even though the sun shield will still be folded at this point, they will present a significant surface area to the solar wind, so that trim tabs at the end of each pallet are deployed to help adjust for that. And then the most critical step is the sun shield, or the heat shields, as they pull up the 5 layers of metallized kapton.
What is Kapton?
It's
Very
a kind
strong plastic.
yeah.
Okay.
And this is the thing that they had the most trouble with when they were developing it. And several times it was the reason for the most recent delay of a couple of years. When they deployed the shields in the lab, they tore. So that's the origami part of it.
Origami. So the sun would be behind that, right? Down below our screen.
Yes.
Well, the sun is not going to shine directly on any of this.
I know, but it's that big wide part is what keeps it from getting sun's rays to screw up.
Well, it shines on the side of the sun shield.
Infrared from space, but not from the sun.
Yeah.
Wow, fascinating.
That's amazing.
And they got radiators and cryo coolers, computers on board. Imagine if it's got batteries that have to be stoked up later on. They're probably charged when they launch them, and they just start going down until. Wonder if they ever
couldn't have batteries because there will be periods of time when it's in the Earth's shadow, so the panels won't be generating any power for them.
Oh,
Jerry, do you know how large the segmented mirror becomes?
It's very big. It's much bigger than the what is
Hubble.
it? You mean each individual segment? It's much bigger in total than the Hubble, of course, but I don't recall the area of it.
Yeah.
and
Okay.
it'll be
Chuck, you know, Chuck?
I think it's 21 feet. I'm just
That sounds right.
Okay.
what, the mirrors?
for the diameter.
The diameter, the effective diameter. So considerable more light gathering power, if you like, than the Hubble.
Yeah.
The
And
Hubble
also
is 8 feet across.
But now, infrared is part of the visible spectrum, is it not? We can see.
No,
No, it's not
No,
visible.
it's
you can't see infrared.
We can't. So it all has to be turned into what we can see before being sent here or after being sent here.
Yeah, it has
Well,
a
it's just
camera
data,
that can
Ron.
see
You can
infrared.
turn data into something you can see very easily.
Right.
Okay.
Right. Yeah, Ron, infra means beyond. So beyond the ray.
The mirror is 21.3 feet in diameter.
Okay,
6.5
thanks,
feet.
Bruce.
Okay. I thought it overlapped at the end, when the lower end of the color spectrum, right? It's infrared, the higher end is ultraviolet. Is that
Right.
Mhm.
But those are the two ends you can't see.
Okay.
Right. Very complicated thing.
Interestingly enough, there's a bunch of animals and insects and stuff that can see both into the ultraviolet and they
Right.
can see a little bit into the infrared, but people
Yeah, they
can't.
have 4 types of color sensors in the back of their eye. We only have 3.
Yeah.
Yeah, you should see what a bee sees.
Yeah.
It's amazing.
But this is going to look deep into deep field type space, right? Trying to find even earlier galaxies than the Hubble.
Right,
did.
because those
Yeah.
wavelengths have been shifted into the infrared.
That's right.
Gotcha. Fascinating stuff. Okay, gentlemen.
And there's no way
Here's-
to get out to it to repair it. So
Hi.
gotta work.
It's about 4, it'll be parked about 4 times the distance of the moon's orbit, won't it?
Yeah,
That sounds about right. Yeah.
All right.
roughly a million miles.
Okay. Well, I hope it doesn't go bad. You know, the chances, how many different things? 30, or is that just the number of days? 30
That's
days.
the number of days. That's the duration. In order to pull out the shields, the Kapton shields, there are 400 pulleys and miles of cables to accomplish the unfolding. Now, when I was working in aerospace, the rule was to minimize or completely eliminate every mechanism you could have, because every mechanism was a potential failure point.
Yeah.
So if
yeah.
you have 400 pulleys up there and every one of them has got to work perfectly, that's fairly high risk. So that's why it took them so long before they were happy with it.
And they've tested those suckers inside some big vacuum space.
Yes, they did. They unfolded in a giant clean room. And what you're looking at in the video now is them assembling the telescope, the James Webb, into its shipping container. See there, it's all folded up and hugging itself. And now it's going to be laid down in the shipping container.
Well, actually, they're taking it out of the shipping container
Oh, that's
at
that what they're taking it out?
Europe Spaceport.
So JPL isn't going to be following this, maybe? Somebody
Of
else?
course they are.
Well, it will be JPL, even though it's ESA, South America.
Well, it's a collaborative effort. ESA is helping to launch it, and they made some of the instruments.
But isn't there usually a main control room? Like Perseverance is JPL, right?
Yeah.
Okay, so
It's automated. They're just going to hear how it went. They don't do anything from ground. The first half of that video was definitely packaging it because I saw it go in the box and I saw people seal the box up. I know the caption said unpacking, but I guess the second half of that is unpacking.
Yeah.
if something doesn't go wrong and it doesn't work, and heaven help me for saying this, how many billions? It's more than
It's lots.
Yeah, it's a lot of bucks.
Right.
That's
So there was a wonderful article on this. I can't remember if it was astronomy or Sky and Telescope, talking about the advantages of all the delays. So this thing, I think it was designed in '89, something like that. And it was supposed to take 20 years, okay, for it, but it took 32. And in that time, so we know about dark energy and all these things this thing might be able to explore. Okay, and so this kind of tweaked the assignments of this thing a little bit too on the way. I think it was in Sky and Telescope, but it was water. Oh, maybe it was in Science News. It was in Science News. Okay, the most recent one we got here is a fabulous article on the advantages of the delay and the things that this thing is going to look for because of the delay.
That's good politics to turn a program delay into an advantage.
Yeah, yeah.
A lot of program managers dream of that.
Yeah.
Wonder how many technicians and buildings and
Thousands.
workers, they all contributed.
By the way, I just calculated the f-stop of the mirror. It's f20.2. It's got 131 meter focal length, and it's the approximate diameter, because it's not round, to 6.5 meters.
Right.
Wonder how much gold is on it. Gold-plated beryllium.
Not very much.
What?
It's only 100 angstroms thick,
Oh.
100 micrometers,
It's gold
1,000
plated.
angstroms.
That reflects better than anything else, gold?
In the infrared, it's the best reflector.
Is that right?
Yeah, I just found the Science News. I was going to mention, if somebody wants to look this up on the web, it's the issue for October the 9th this year and October the 23rd this year. It's a fabulous article. But again, the main theme of the article is the advantages of the delay,
Well, they didn't put the time of day on December 18th, but I hope it's not in the middle of the night. We'd probably all like
We
to
won't
hold
be
it.
able to see it from here anyway.
South America.
It's yeah. It went through the Panama Canal recently. It's to where it's going to launch.
You'd see it on television for sure. They probably will have
Yeah.
it on.
That thing, isn't that amazing? How big it is?
Yeah. Stupid question, but is there such a thing as a radio telescope for ultraviolet?
There are
Radio
ultraviolet
telescope?
telescopes.
No, I never heard of that.
No,
We have,
no.
Well,
Yeah,
if
that's
it gets
ultraviolet
stretched
telescope.
out enough, it becomes radio waves.
well, that's true.
Yeah, the Hubble can see ultraviolet. It's some
Yes.
bit into the range.
Yeah, a little bit.
Well, everything we see in space, right? That broadcasts everything from gammas to X-rays to ultra to infra.
Everything, depending on its temperature, has a wavelength or a color band that it emits most of its light in. And so we
Okay.
talk about those things that are very, very cool or very, very red shifted. They will show up with their peak emission out in the infrared or the radio waves, very long wavelengths, things that are around 6,000 degrees Kelvin, that like the sun, that will peak in the mid of our visible. And that's why our eyes are matched to that. And so the sun emits at that wavelength in the peak. It's the Planck radiation law. And if
We
you get
have
something that is super, super hot, you can get its peak emission out in the ultraviolet.
We
What happens
have
with-
a small radio telescope, you know, maybe a 1 foot diameter parabola that Jerry Polivka, one of our members, designed. And we would bring those to school outreaches when it was either cloudy or we were doing it during the day. And you could not only detect things like the moon and the sun or TV satellites up there that are broadcasting, but you could point them, the students could point them at each other and see that they were emitting in radio waves. So you could have a student stand there and another student would scan the little radio telescope across them and you'd see a peak as they went by the person.
They glow reddish in the dark.
People glow in the infrared and radio waves. Yes, they do. Otherwise,
And
it's
each
dark.
person dissipates about 100 watts. We're warm.
I think I'm down to about 60 watts at my age.
But all your optical telescopes are in a tube or at the far end of a tube. They don't use tubes on radio telescopes at all for some reason. Curious why that is. This one
They're not real small. You don't want radio tubes. They're fragile. They're not rugged, and they take up a lot of space.
Right.
You don't need a tube on a telescope. That's just there to keep stray light from getting in.
Right.
That kind of tube. I thought you were talking about electron tubes,
No,
like in
no.
the radio sets from the 50s.
No, Ron was talking about physical tubes.
Oh, okay. Sorry.
Well, no,
I
but
had a guy that used to just bring a 2x4 with a mirror at one end and a secondary mirror mounted on the other end, and that was a telescope.
Yeah.
Yes.
If you were in a
Jürgen?
very dark field, that would work fine.
Yeah.
on the
Jürgen brings a minimalist Dobsonian. It's just a rod and something to hold the secondary, and the mirror is down below. Everything's wide open. You're looking at it all. There's no
Yeah.
tube.
but now the infrared is below the color spectrum, right? So that's all the radio waves. They're longer wavelengths are all below our visible spectrum. Is that a fair statement?
Low in energy, yes. Longer in wavelength.
Okay. And so radio telescopes like those VLAs out in the desert,
Right.
they're lined up. They're giant.
Yeah. Yeah,
Obviously,
that's what Tom is showing right there.
Okay. And yet that's where we concentrate on the non-visible spectrum below the colors. Nothing above, I guess we do
Well,
get
no,
it.
you see the atmospheric transmission, it absorbs everything in the infrared because of the water in the air and other molecules. That's why we're putting the James Webb up, is so this infrared radiation can be now imaged because it can't get through the atmosphere.
Yeah, Ron, you see this graph here, those brown areas, the higher they are, the less you're seeing. So radio waves come through the atmosphere easily, so that's why we observe with those.
Radio waves?
Yes.
Oh, I see. The ultraviolet and above doesn't gets stopped by
You see the rainbow over here. That's the visible bands, and you see most of the visible band gets through very well, and that's what our eye can pick up. And then all these choppy peaks of brown right here, those are different molecules taking out infrared radiation until finally you get to really long infrared radiation, about 50 microns, and then there's just nothing gets through. The Earth looks white at those levels, just like Venus looks to us.
Yeah.
Visible.
Okay. There's no telescope, radio, or optical on the Earth's surface that could have picked up what the Hubble did in the deep field. There's no way we'd ever.
No, the Hubble is a visible telescope.
Yeah, okay. All right. And it's out beyond the Earth's atmosphere and therefore not subject to any of those problems.
But the main thing that you get an advantage from the Hubble is that you don't have the atmospheric turbulence.
Oh, yeah, right.
Or scatter. You get darker backgrounds.
Okay, now those distant galaxies, the further away they are, the more they are in infrared or on the red shift, right?
Yes.
Yep.
Any galaxy that's shifting to ultraviolet would be coming at us, like Andromeda.
Yeah.
Did we-
There are a few.
It's not coming that fast to get into the ultraviolet.
Yeah.
Oh, it's not. Okay. But ultraviolet, I've always understood to be hotter stars or heat,
Yeah.
like blue stars or ultra.
It's more energetic.
Yep.
Okay. And does it butt with or go right up into the gammas and X-rays? Are they right above ultraviolet? Or is there a bunch of areas in there?
Well, it's just arbitrary, Ron. What you call some of these things? They're pretty wide bands, some of them.
Mhm.
Well, I do know that X-rays and gammas are really short. I just learned from the president a couple of weeks ago that an atom thick is the what do they call that? The wave?
Wavelength,
The what? Yeah, the wavelength.
the wavelength.
Yeah.
Insane.
Yeah. Gamma rays and hard X-rays are two names for the same thing. But
Oh, they
generally,
are.
it's gamma rays is the most energetic, then X-rays, then ultraviolet, and then you're down into the visible.
But we'd never have a dentist office operating with the gammas in your mouth, would they? That's a little too much.
No.
Yeah, you just want to image. You don't want to damage.
Yeah, you'd have to dispose of the body later.
Okay, have we pretty much exhausted that? Because there's stuff on your list like the Messiers, the start of the catalog, and that incredible comet. My notes on the
Well, the
comet.
Messier thing, I started with pointing out that this is first object in the catalog is M1, which I have in my mind as a planetary nebula, but then Chuck always points out it's a different mechanism. It's the result of a supernova.
Supernova. It's a
Yeah.
supernova.
So, but it looks like a planetary. It's very dramatic. It happened, what, 1054 AD?
Yes.
Or July 4th.
Okay.
Yeah.
In China. I didn't know they had July 4th in China, but and you can take a picture of this, or rather astronomers have taken a picture of this 100 years ago and today, and you can see that it's grown and the structure has changed and moved out. So it's expanding as we watch.
The old crab.
And
Oh,
there's-
that's the original, that's
Yeah.
the discovery drawing from Herschel, I think it was.
So this is
Lord
Lord
Ross.
Ross.
Yeah.
So this is with the big telescope in Ireland.
Yes.
Yeah.
And this is a visual effect and a drawing, and this is where it got the name the Crab Nebula. But even that to me does not look like a crab,
Mhm.
more like a shrimp. But
Yeah.
An exploding guitar.
Looks like a fennel plant to me. Looks like fennel.
that could be pineapple.
Yeah.
I guess he's never been to Hawaii.
Yeah. There's also indication that the Native Americans in Chaco Canyon in New Mexico witnessed the thing because when it went off, it went off a long, long time before people saw it. But when they saw it, they drew images on the canyon walls in Chaco Canyon. And apparently there was a moon. So there's a little crescent moon there and then this thing, okay, in Chaco Canyon that they drew. So it was
I've
visible all
I've seen
over.
that petroglyph.
Yes, yes.
Tom, you're changing images too fast. I can't follow
Yeah.
it.
Here,
Just pick one and stay on
Here's
it.
that
There it is,
petroglyph.
there it is.
Trying to find it.
See the moon there? So apparently,
Moon
you
and
know,
then the blast to the left of it.
yeah, Taurus the Bull. It was in Taurus the Bull, and there apparently was a crescent moon when they first saw this thing.
Why does that look like a sofa? I don't understand.
No, it's a
Rock
sandstone.
wall.
It's a rock.
Yeah. Yeah, sandstone wall.
Oh, it's a wall. Oh, I see.
If you've never seen the petroglyphs in the Southwest, New Mexico, Arizona and stuff, it's really dramatic. You really feel a connection
Right.
to ancient people.
For me, the special one is Horseshoe Canyon in Utah,
Hmm.
with the Great Gallery. They call it the Great Gallery. It's beautiful. I've been there a bunch of times.
Are we still?
Painted Cave ain't bad.
Yeah.
Crab Nebula is the first of the Messier catalog. That was the
Yeah.
number
And
one.
Messier did not discover it.
Right.
How
He
did
just
you
wrote
get
it down as number one.
Right.
Okay, well, it said in your notes, it said 1731. It was
See,
discovered.
now
by-
this is an X-ray and infrared.
By
That one
John
you just
Beavis.
had.
This is a what in infrared?
The view that was red and that one, that's the X-ray is the bluish. So you can see it's really whirling around. You don't see that in the visible. And then the red is infrared from Spitzer.
There's a great animation of this with several images combined taken from these various X-ray and radio telescopes, where you can actually see the pulsar pulsing.
Mhm.
Oh, there's a pulsar in the middle of it, a neutron.
Yeah. 33-second.
Normally, in the middle of a true planetary, you'd have a star, a white dwarf, but not here. Here we have the remnants of a supernova.
Here it is.
All these are versions of the Crab Nebula. No two of them look the same at all.
Well, they're in different wavelengths.
Is that what it
This
is?
one, the blue one, is in X-ray.
Is it?
The red one you had before was in infrared. The one
Okay.
that they showed, there's a collection of, all four. They have Hubble, Spitzer, the Chandra, and I forgot what the fourth one. Oh, radio.
Yeah.
And
I
they've
think the pulsar goes at 33 milliseconds, right, Jerry? 33
times a
milliseconds.
second, yeah.
Yeah.
So, yeah. Here they've
Yeah.
got the order of the wavelengths decreasing to the right, where we normally put it decreasing to the left.
Mhm.
So I put gamma rays and X-rays on the right and ultraviolet in the middle. And
Mhm.
Okay.
There's
So
a group of amateurs that put a little rotating shutter in front of their eyepiece that they could tune the rate at which the shutter opened and closed. And they
oh,
observed the
blink.
nebula from a really dark place. And when they tuned it to the 33 times a second, they
Mhm.
could see the central star, the neutron star that's the pulsar.
Huh.
And then when they tuned it off of that rate, then they could see it go away. So
They
it
get
does
a,
have a visual
beam
component
frequency.
as the radio beam sweeps across parts of the nebula.
Mhm.
is it safe to say that all nebulas were exploded stars? What's left over?
No.
They're not.
Mm-mm.
There's two different kinds. One's exploded stars, and the other one is like M42, which is a formation nebula.
Yeah, and then there's planetary nebulae, which aren't really from explosions, but more like just expulsions from the surface.
Mhm.
It-
So
it's-
these
Yeah.
nebula
Births.
represent both the birth and the end of the star's life.
Yeah.
Well, I have in Jerry's notes here where it is in the sky. Anybody want to go there? See if you know.
Taurus.
Taurus?
I've seen it a lot.
Yeah, yep. I
It's
photographed
right near
it.
the lower horn of Taurus the Bull, the tip of the lower horn.
Right.
Well, when it's rising, it's the lower horn.
Alhaca, a star called Alhaca.
Yeah. You can see here the little green square called M1.
Hmm.
Ah, okay. That's the nebula, the crab. How big a telescope you have to use to be able to actually see that it's a nebula, not just a glowing
6
star?
inch. I've seen it in 6 inch.
6
Yeah.
inches.
But
4
you need to
inches.
get away from our skies. You
Yeah.
have to have a dark sky.
Yeah,
Yeah.
you need to be out in the darkness of Goleta.
Messier
There
only
is
had
no
a
such
3-inch
thing.
telescope. Ron, Messier only had a 3-inch telescope, so he could see it.
Did he really?
Right,
Yeah.
but they didn't have electricity back then and lights all over the place.
Yeah.
And he was post Galileo, right? Long
Of
after Galileo.
course.
Yes, yes.
And the ancients saw it explode in 1054.
Yeah, it
And-
was visible for 3 weeks or so in the
Yeah.
daytime sky.
wow.
I mean, in the sky.
Yeah.
Well, now, speaking of that, you did send us a last minute addendum to your talking points, Jerry, that I thought maybe would just at least tease everybody about the old comet Churyumov.
Gerasimenko.
Is that heading to us in a few weeks or months?
It's in the sky right now.
But you can't see it without a telescope.
Right.
Yes, that's right.
Will we
It's that-
ever be?
It's heading for your backyard right now, Ron.
Well, I'll let you know if I hear it or you'll hear it. But I mean, might it turn into a Halley's that we can see tail and
No.
everything without?
No, it's
No, I don't think it's captured.
Oh, it's not. Okay. Well, I didn't write down too much about it.
well, it's right currently it's at magnitude 9.7, almost 10th magnitude. And that's four times past where you could possibly see it with your naked eye. And every brightness, every magnitude change is a brightness of 2.5. So it's much, much dimmer than you can see anywhere from Earth with your eye. So you need a telescope.
Yeah.
Okay, but can you tell, obviously they can tell whether one's coming in or going out, and this one's coming in, right?
In 3 different observations of it, it can be determined what the orbit is. And then you know everything about the motion of the comet at the moment, because it may change, because comets are subject to being blown around by the solar wind and also creating their own rockets on the surface, which adjust their position all the time.
Right. And it may not be on the way, it may be on the way out right now, but it's near its perihelion.
Yeah.
You know, I don't remember perihelion when it happened, but it's either close, you know, it's either coming in just about to reach perihelion or just past it and heading back out.
Do we know which planet in the solar system or which planet's orbit it's near?
No, it's in a long ellipse. You know, all these short period comets are sort of Jupiter family comets that have been influenced by the gravity of Jupiter.
It's not coming anywhere near us. It's about the same brightness as the Crab Nebula.
Okay.
So it takes about a 4-inch scope to see it.
Is there a common point in the solar system? How far out do they usually get a tail? Does it get hot enough?
It depends on the composition of the comet.
Yeah.
But that is the definition of a comet is a from the Kuiper
Hairy
belt,
star.
They used to call it a bearded star.
a bearded star. And this one has a tail.
Yeah.
It has a coma at least. I don't know how much tail you're going to see.
Oh. Muamua came through and didn't have a tail, did it? It didn't have any.
It had a slight coma of something, hydrogen or something.
Did you hear about that back east professor of astronomy at one of the big universities that believes it was an interstellar?
Oh, yeah.
Oh, that's the Muamua guy. Yeah.
Yeah.
Right. Yeah, he's a Harvard prof.
He was speculating it could be, not that he thought it was.
Yeah.
Yeah. Okay. Fascinating stuff. Shall we go to Venus and another Messier H?
Well, that happened on Saturday, so I don't know.
Behind? Well,
Hey,
anybody?
Ron,
The point is that Venus is traveling right now through an extremely rich portion of the Milky Way in Sagittarius. Over the weekend, it was passing by the Lagoon Nebula M8.
Right.
At any time, this is a good opportunity to take pictures of Venus in these different regions. But Venus is so bright that it's a challenge you're going to have to take 2 pictures, one where Venus is blown way out and then another of Venus, and then blend them together into the right position to show everything good and not saturated.
And there was a good conjunction of the moon and Venus last night. Tonight it'll be farther away.
Yes.
Yeah,
It was very pretty.
I was about to mention that. It was absolutely beautiful. And it turns out my nephew lives near the East Coast, and he took a photo of Venus and the moon from his perspective, sent it to me, and you could see that by the time we saw it here in the backyard, the moon had clearly moved towards Venus. It was really fun to see that.
But below the middle in that picture is M8, that little square. That's the Lagoon Nebula.
Yes.
And is it the remnant of an exploding star or the other types?
No.
It isn't.
No.
What makes it a nebula then? Just because it's a patch of.
It's a cloud of
It looks like
fluorescing hydrogen.
Nebulous cloud in Latin.
Before we leave comets, can I show you a picture I took of Comet Holmes with the coma?
Yeah.
How can you? Sure. If you can get it on the screen.
Yeah, how do I share? Oh, there it is. See that?
That's nice.
Yeah. So there's the nucleus, and there's I guess this is a coma going back, and the tail starts leaving out here. This is a bow shock wave as it's passing through the sky.
Yeah. I remember seeing that at the workshop on Tuesdays for a little bit. We could see it very easily.
Yeah. It was a fairly bright comet.
Quite bright.
Yeah.
Shouldn't there be a tail going up?
Yeah, the tail
right there.
would be going up. But I exposed for the head of the comet here.
And Jerry, is it true that it was named after Larry Holmes, the famous boxer?
On hold.
Wasn't named
I
after
don't-
Sherlock.
I don't think so.
Right, that's good.
Well,
Wow.
if we get a Dr. Watson comet, then we'll know.
That's a
But no,
great
it looks
photo.
like a bright star in the middle, and yet that's just a little rock that's more
Yeah.
intensely.
No,
Yeah.
that's not even the rock, Ron. That's just more gas around
Yeah.
the actual comet head.
That's concentrated gas that's about to flare out and follow the path back to being part of the tail.
Yeah. You can see
Okay.
how
ahead.
faint, how see through, if you like, see through the cometary structures, because you can see distant stars right through it easily.
Yeah.
Mhm.
Now, this is a single shot subframe and it's not processed. So these red dots are not stars. Those are hot elements in my camera.
Okay.
It's a DSLR.
Now,
Okay.
every comet that shows up isn't some rock out in the Oort cloud or the Kuiper belt that decided to move in or got affected. They've been coming in and out for millennia, haven't they? Forever.
Since the solar system started.
Yeah,
Wow. Including
that's
Halo.
nice.
That was the first one. Fascinating stuff. Great picture.
Yeah.
Here's Venus and the moon last night from
Oh, nice
my
job.
house. Oh, we got a power
Oh, yeah.
wire
That's very
there.
good.
I
What
was,
is that thing that looks
but-
like a bucket being held on a rope from the covering the moon?
And tonight
the
the
moon was
will be-
very orange last night when you took this. It was pretty.
Go back to
Yeah.
the previous. Go back to the
The moon-
previous picture.
Yeah,
The
the
previous
moon will
one?
be above Venus tonight.
What's that thing? It looks like a bucket on a rope.
Power line.
Oh,
Yeah.
power line. Yeah. Okay. Good.
Yeah,
Thank
that's
you.
an insulator, Jerry. Or, something.
It happens a lot. That's
You
what
changed it from a UFO to a KO.
It's a beautiful shot.
great pictures, man. I got to tell you, I
Yeah.
love it.
Nice job.
Oh, that's cool there.
I
Yeah.
like that. Tom, if you want that in the newsletter, send it, that one.
Kind of messy, a little bit dark.
No, it's
Oh, it's
not.
just pretty because you get the background with your backyard.
Yeah.
Yeah, it gives you the scale.
Yes,
Yeah.
exactly.
Uh-huh.
That is a shot. That's an artistic.
There. That's perfect.
Yeah.
Recent or many years ago? Or
No, that's last night.
This
Oh,
last night, Ron.
Oh, okay.
And you know, apparently sometime after that, you know, the moon went right by Venus, but we didn't see that because the moon had set with Venus by that time.
Well, over the past year or two, didn't we have several planets, 2 or 3? Mars was also up there with Venus next to the
Yeah.
moon.
Yeah.
Yeah,
That's
yeah,
what happens.
yeah. I think it's in December that Mars and Chuck, correct me, Mars and Mercury will be a morning object.
Yeah.
Be pretty- Yeah, okay.
Gentlemen, we're
And
getting
I think in also December, so people, you should watch Venus and Saturn and Jupiter. So they're going to line up really nicely. So you
really.
get a view of the ecliptic, if you like, through them.
It'll kind of be moving lower on the horizon though. So that
Yeah.
will kill it a little.
Now, as they are pretty far down.
Well,
Yeah.
well, coming up just next week on the 18th, we get a really deep lunar eclipse too.
Yes. Mhm.
A lunar, they shadow the Earth and the moon.
It's a penumbral eclipse, but it's very deep, so it's almost total. 3% of the moon won't get covered.
Chuck, do you remember what time that is?
It starts at like a little after 11 p.m. on the 18th for us, but the main date is the 19th,
Okay.
early in the morning. It ends at like 3 a.m. or 4 a.m.
Okay.
That'll be the same for everybody on Earth, unlike a solar eclipse. It's a track across, right? This is different.
Well,
The
some
moon
people, yeah, when it occurs, will be in daytime, but
Yes.
has to be a full moon, right? Obviously.
it's full moon on the 19th. Yes.
Yeah.
Gotcha. Before we go real quick, as long as we got you on, Mr. Outreach, any outreach going on other than us?
We're doing a couple of non-public events. We've done a couple of little school things, and we're doing a hotel thing. And there's a corporate thing coming up, but we're talking about restarting the Santa Barbara Museum of Natural History monthly events on the second Saturday. So that might happen in December. We just got to watch and see how COVID's behaving.
Oh, wow.
Right.
But
Nice.
no,
I have a limited pool of people that can participate in that because we have to be, there's the normal certification we went through with the background check, but now also the museum wants proof of vaccination.
Mhm.
So I have about 7 people so far that have gotten that into Rebecca Coulter at the museum that can participate.
So we
Okay.
just make a copy of our vaccination little card and send it to her.
Yeah, you can do it as just a JPEG or a PNG, and send it to Rebecca Coulter, and you're good.
And then the
So
folks.
Chuck, I
Go
did a star party at Death Valley on Saturday night. The Furnace
you?
Creek Death Valley is part of
Wow.
the Atheist United group. Evidently, they held this thing, and they had a speaker, a girl from Davis, science teacher, come in and do the talk, and I kept my mouth shut most of the time. I set up my 12-inch Dob there, and it had a pretty good sky. It wasn't perfect, but it was, Milky Way is pretty visible.
So
Except for
Tom,
headlights coming in into the parking lot of this borax refinery, old refinery place.
Yeah.
They tried to find a dark spot, but then there was no control and just people driving right through, and
yeah.
50 or 60 people. It was
Well,
kind
that's
of
where
cool.
roofing bells help a lot.
So Tom, was God not
You
invited?
seed the road with them.
Exactly.
Did it have the second coming out there in the desert?
Oh, but I heard Nietzsche was there.
Right.
Did the folks who brought the telescope get it working?
Yeah, I had it working with them the night before, but they didn't set it up for the star party time.
Oh.
I got them to set it up on Friday night and check it out, and
Okay.
showed
So
them
you
different
didn't bring
things.
your own scope out there then?
Yeah,
No,
you
I
did.
did. I had my 12-inch Dob. Yeah.
Okay.
Can't wait to see the pictures.
So the
That's
club
what we-
also received a nice donation of an 8-inch mead.
Yeah. Another scope.
Recently?
Do you recall who donated that?
Brian Wise, I guess.
Yeah,
is
Brian Wise. So
name of
thank
the
you,
family.
Brian. Yeah,
Is Art Harris
So-
got it?
yeah.
We'll
Art has
pass.
it.
Hopefully, we'll pass that on to somebody who needs a
Yeah.
good scope.
He says it's working fine.
Art doesn't have enough Meade telescopes.
Yeah.
Gentlemen,
He's
we've
probably
reached
got a
the,
dozen.
we're past the hour mark. You want to wrap this
Uh-oh.
up? And go
Okay.
sanitize our masks, go wash them, and get those incredible one of the cars you guys are driving, those Teslas, washed and recharged. And thank you all, the two Toms
Yeah.
and Bruce and Chuck and my good friend Jerry Wilson, the president. We'll see you all next week.
Yeah, thanks a lot. Thanks a
Yeah.
lot, Tom, Ron,
Yeah,
everybody.
Thanks,
All right,
everybody.
good night.
Got it.
Good
Thank
day,
you.
everybody.